All right, welcome back to Level 6 Math. I'm Mr. C with Saxon Math Lesson 110. Today we're going to talk about symmetry. So we see that a figure has symmetry if it can be divided in half so the halves are mirror images. If you think of butterflies, leaves, most kinds of fish, those are all symmetrical. Humans are also symmetrical, like this half of me looks about the same as this half of me. It's just a mirror image. Not exactly, but pretty close. And even two-dimensional objects like this triangle, it can be symmetrical. The line of symmetry is the one that divides it in half. So if you can have a line and then both sides are a mirror image, that's the line of symmetry. So how many lines of symmetry are in this rectangle? Well, we can just put a line in half and see if it's the same on both sides. So if we did one down here, yeah, we'd have that side and that side. If we did one here, it'd be symmetrical on the top and the bottom. What if we did it from corner to corner? Would that be symmetrical? Well, if we fold it in half that way, and you can do this with a piece of paper, no, it's not going to match up perfectly. So we really only have two lines of symmetry. We have that one and this one. All right, so which of these triangles does not appear to be symmetrical? Now this is hard because on triangles, right at first glance, they all look symmetrical. So we can draw some lines on here and see. Yeah, that's exactly the same. What if we did a line of symmetry that way? Yeah, that's also the same. On this one, we could do a line of symmetry that way. If we did it that way, it wouldn't be symmetrical, but it has one line of symmetry. On this one, if we go through, that's not exactly the same. If we go through that way, it's not exactly the same. And if we go through that way, it's really close, but this one's a little higher off, so this one does not have a line of symmetry. So it's going to be A and B that are symmetrical. So there's A, we just drew those three lines. So it does have a line. B has one line of symmetry, and then C doesn't. Okay? Now there's a different kind of symmetry. This is called rotational symmetry. That means if you can turn the object or rotate it, and it looks the same in a different position before you've done a full rotation, then it has rotational symmetry. So this is easy with squares. You turn it 90 degrees and it looks exactly the same. Turn it another 90 to get to 180, it looks exactly the same. So a square definitely has rotational symmetry. A perfect triangle would have rotational symmetry. If we look at these, which have rotational symmetry, well, if we turn this one once, it doesn't look the same. But if we turn it twice, if we turn this one 180 degrees, it'll look exactly the same. Same with this one. If we turn this two times, it will look the same. But these two, if we turn them upside down, they look different. They're not the same. They would be mirrored. And so A and B on this one have rotational symmetry, but C and D do not. And you can just, if you have this in your book, you can just rotate your book to see if it looks the same. So that's an easy way to do that. In this one, A and B have rotational symmetry. And that's it. This is a quick lesson today. We're just going to practice looking at symmetry and rotational symmetry. So you can go ahead and head over to your practice problems. All right, good luck.